Now we are going to understand that what would be the amount of the magnetic field and direction at the axis of a current carrying coil which is circular. So to understand that, just observe very carefully about the three-dimensional structure. Let us say, for example, that this is a current carrying conductor, a circular loop, right? This is a wire, so this is the thickness of this wire and this is conducting the current. And now let us check that over here, this is the center, so the axis will be somewhat like this. Let us check that this axis is in X direction, right? And likewise, if we check this one over here, then we shall find this as in Y direction, and likewise this in the Z direction. So observe carefully, this is a current carrying conductor, right? And like it is kept in the YZ plane, right? Likewise. Now if this is a YZ plane, then obviously the x-axis will be like perpendicular to the plane of this current carrying coil, right? And thus, if this is the center, this line will be the axis. Now let us check any point on this axis as we are to find out the V and the axis of a current carrying coil. First of all, over here, this coil has got a radius of R. Now let us check a point over here. Say this point, right? And this point, like over here, if we take at this particular point, we are to find out the B or the magnetic field at point P, right? So we know that we are going to take a very small part of this entire loop. Let us check, for example, this part, okay? And if we go over here for this small interval, we may see that the current is flowing in this direction, which means actually the current is flowing in this direction likewise. Right? Now, observe that where on which axis actually this lies. This DL, if we take as this one as DL, then see that this GL is basically parallel to the Z-axis. This is on the top, the topmost area of the coil. So if this is very, very small, then obviously this GL will be parallel to the Z-axis because the entire loop lies on the YZ plane, right? Now from this particular point, we have to measure that for this particular point, what it is producing the magnetic field at the point of B. So let us draw a line over here, like this. And if we take that from origin, from O to P, if it is, say for example, X, and from this point to P, let us check this point as A. So the AP length, let us check it now, for example, as A. And angle, what it is making with the x-axis, let us take it as alpha. Or to, like, there will be confusion, there might be a confusion between A and alpha. So let us take it as beta. Right? Now, this is good. Now, this DL is parallel to the z-axis. Right? So, if we write over here, DL, this is parallel to z-axis. Right? DR means the distance from this point to this point. Okay? Or AP. This AP is basically parallel on the, it is lying on which plane? Or to be precise, it is lying on this X and Y plane. Right? So, we can write it as that it lies on XY plane. Right? Because AP is a line which is lying on the X and the Y plane. Right? It is not coming over here or not going over here. So it is not on the Z axis. Right? Now we are going to find out the angle between DL and AP. That is called theta. And the sine theta we have to calculate likewise. Now see over here, XY plane and Z axis. Right? This is the XY plane, this whiteboard. Z axis means it will be like this, either coming to you or going inside the whiteboard. Means it is obviously making 90 degree. Right? So over here we can understand that the theta is equals to pi by 2. Or in this case the sine theta will be equal to 1. Because sine of pi by 2 is equals to 1. Now let us look. We know that for this particular DL, it will be throwing a dV. It will be producing a dV. So the dV will be equals to, do not confuse this B with this angle beta. This is simply beta, not B. Okay. So the dV will be equals to mu naught divided by 4 pi multiplied by I dl divided by, now this is I, right, the amount of current which is flowing, multiplied by this GL and divided by what? The distance, the separation of the distance square. This is simply A, right? So we can write A square multiplied by sine theta. And what is the value of sine theta? The sine theta is equals to 1. We have found out. So we can write that B dB is now equals to mu naught divided by 4 pi multiplied by I dl A square, where we have considered this like in a free space. That is the reason why we have written this permeability as mu naught. Now, the main concept. We know that the direction of the bead, what will it be? We know from the very first lecture of Biot-Savart's law, this was something denoted as like this, right? Now what is this R over here? This R is basically the A. So we can replace this R by A. So some cross product is going to happen. That is the reason why sine theta was over here. But the direction will be as per the conventional rules of cross product. And we know that the direction of the cross product will just be according to the corkscrew rule, right? So, the direction of this small dB, it will be perpendicular to this A, as well as it will be, see, it is perpendicular to A, which means that over here it is 90 degree, and also this dB will be perpendicular to DL, means it will be perpendicular to this line AP, as well as it has to be perpendicular to this DL, means the Z axis, right? Now, if we do resolve this geometrically, we could find out, like, say for example, this is beta, right? And if this one line we have drawn, so these two angles will be equal to 90 degree. Let us say, for example, take this angle as equals to X, this angle as equals to Y, and let us not take XY, let us take this as like I, J and K, right? So, from geometry we can understand over here that beta plus I is equals to pi by 2. This one plus this one will be equal to 90 degree. Again, we said that dB will be perpendicular to this AP line, which means angle I plus angle Z will be equals to 90 degree or pi by 2. J plus I equals to pi by 2. Right? Now, if this is the scenario, and if we are going to subtract like this second equation from the first equation, we will get it likewise, that beta minus J, and this I will get cancelled, is equals to pi by 2 and pi by 2. This is plus, this is minus, this will be equals to 0. Which implies we can write now that J is equals to beta. Now what is J? J is this angle. So we can write now that J is now equals to beta, this particular angle. Right? Now observe that if this is a vector and we wish to resolve this vector into its rectangular components, and this is like beta, we can take this and this. So this part, it will be dB cos beta, and this part it will be dB sin beta, right? Now closely observe, we are now taking another DL just below it, on the lowest corner. We have taken this again the same length DL. Likewise, if we draw this line from over here, this will be somewhat like this over here, right? This is a straight line obviously, and if this is a straight line, again there will be the dB for this particular thing. The dB would have been 90 degree, making from the C, for example, it is C point. So CP perpendicular to CP. So this dB is actually for this DL now, and this dB is now actually for this DL, right? And since this is a beta, this would have been also equals to beta. By geometry, we could find this, right? Or else you can say very clearly that this angle plus this angle equal to 90 degree, and this angle plus this angle equals to 90 degree. So we can say that this angle is equals to this angle. So if we do likewise over here, this will be beta, right? Because this is from the center. This is the axis. So the upper or the topmost part and the lowest part will make the same angle at any particular given point on the axis. So likewise this will be beta and this will be beta. So if this one is beta angle, this will also be beta. So we can write over here that this portion is, we can resolve as dB cos beta, and this portion we can again resolve as dB sin beta. Now look, this dB cos beta is actually opposing this dB cos beta. So always in the loop we will get that this and this, the most opposite points, will cancel out the cos components of that B, right? Because this dB was creating this dB cos beta, and now this dB has created dB cos beta, and they are simply like opposite to each other. Because the value of dB will be same, because this DL is for the same DL. The current is flowing, the I is same over here as well as over here, right? And this amount, this CP, length of CP will also be equals to AP. Because this line of the x-axis, it is just the axis of this circular coil, right? So we can say that this dB cos beta and this dB cos beta actually cancels each other. So the only remaining component is dB sin beta and dB sin beta. And we could see that they are actually going in the same direction. So dB sin beta, or the sine component of each and every dB, now will add up, right? And from this, so for this we can write that now this is dB, so we can write that B is equals to integration of mu naught divided by 4 pi multiplied by I dl divided by a square from 0 to 2 pi r, because 2 pi r, this is r, the radius of this circular coil is r, so the total length will be 2 pi r, or the perimeter as we have seen in the previous lecture, multiplied by the sine theta. Why? Because we know that whatever now we are going to find out, that will simply be dB sine theta. Because this dB could be like, they could be resolved in two components, dB cos theta and dB sine theta. So actually now we have seen that B is equals to the integration of dB sine theta, right? So dB was this term we have put over here, and sine theta as this term we have put over here, and this will be the integration from 0 to 2 pi r. Okay? Now, from the laws of trigonometry, if we do again come back and see in the triangle AOP, we could find that sine beta will be equals to this one. What is this? This is simply the radius, radius divided by this one or A, right? And applying the Pythagoras theorem, we can write that this is the hypotenuse of this right angle triangle. Then the value of A will be equals to under root of r square plus x square. Under root of r square plus x square. So this is the value of sine B. Beta. We could write over here this one not as theta because this is beta over here. So, and likewise this will be beta. Right? So we can put mu naught divided by 4 pi. This is simply a constant. I won't change. If we are going to change the logarithm of dl, I won't be changing. So I will outside. Now we can write it as mu naught divided by 4 pi multiplied by I divided by a square sine beta integration of dl from 0 to 2 pi r. This will fetch us the value. This is sine beta, so we can write b is equals to mu naught divided by 4 pi multiplied by I divided by a square and multiplied by, first of all we can write that this is r divided by a as like this is sine beta r divided by a, and the integration of dl from 0 to 2 pi r, that will simply be equals to 2 pi r. So multiplied by 2 pi r. We could cancel out this pi with this pi, and 2 could cancel out this 4, leaving only 2 on the denominator. So we can write beta, or the B, the magnetic field B, as equals to mu naught I r square divided by 2a cube. But we are not going to take a tape and measure this distance of A. Obviously not. We are going to measure that what is the r, the radius of this current carrying coil, no? And what is the distance of this particular given point from the center. So we have to make everything in the terms of r and x. This is not acceptable right now, but we can put out the value of A as under root of r square plus x square, or r square plus x square whole to the power half. So we can write it as B equals to mu naught I r square divided by 2 multiplied by r square plus x square to the power 3 by 2. So this is simply the expression of the magnetic field at the axis of a current carrying conductor or a current carrying circular loop. Right? And what would be the direction? It is as simple as that. We have seen that the cos components cancel each other, only leaving the sine components, which is actually along the direction of this axis. So, if you take out again your right hand, just fold your other fingers of your right hand according to the direction of the eye, you will see that the flow of this B of the magnetic field will be along the axis. Right? So now, over here, say for example, we are going to check out that the formula or the expression which we have deduced in the previous lecture about that what would be the B of this current carrying coil when this we will be measuring not on the axis axis but at the center of this loop, as we have seen in the previous lecture. So in this scenario, what the value of x will be? It will be simply equal to 0 because we are going to find it out over here. So there will be no x, right? So just simply putting x equals to 0, we will get this expression as b equals to mu naught I r square divided by r to the power 3, because r square 2 r cube, because r to the power 2 and 3 to the power 2, so it will simply be equals to r to the power 3. Look out, the r square will cancel out this one, leaving only r on the denominator, and really we have seen the expression over there as that b was equals to mu naught I divided by 2r, right? So this is basically the general solution or the general expression for the magnetic field or B at any point on the axis of this current carrying loop or this circular current carrying coil. Thank you.